Hello, everyone. This is Physical Science, and we are working on some extra math problems on force and friction for Module 7. Our first problem is right here. You need to push a 10-kilogram box 40 meters south. If static friction is 35 newtons north and kinetic friction is 25 newtons north, how much force will you need to use? Okay, so let's draw a picture of this. We've got our box. It's 10 kilograms. And we need to push it. It's a big box. Well, not really, but here we go. We need to push this west, right? No, south, excuse me. Let me erase that. South. So we need to push this south. Okay, remember friction is fighting this, and we're going to make our friction into a blob which really doesn't like us. It doesn't want to move us. It's like glue on the ground. It is stopping that movement. So we have to fight against the friction, and we also have to move the box. Okay, so static friction in this case, see, if static friction is 35 newtons north, so static equals 35 newtons north. So remember, static, start. This is the friction you have to fight to start it. Okay, remember what you need to fight 35 newtons north is just a little more than 35 newtons south. Kinetic friction is 25 newtons north. So once you start it, it's just barely creeping along. So kinetic means moving friction. It's 25 newtons north. It's moving friction. Remember, kinetic, when you see it, it always means moving. So in order to keep it moving, you will need a little more than 25 newtons south. So it's just going super, super, super slow. But that fights against our friction down here, our evil friction blob. Now, what if you got tired of just pushing it a tiny little inch at a time along the floor, and you want to accelerate it a little bit faster? So if we want to accelerate it at, say, half of a meter per second squared south, we're going to have to add whatever force it needs to accelerate it into what we needed here and what we needed here. So first, let's figure out how much force it would need to accelerate it. Well, what you use is force equals ma. M is the mass, a is acceleration. Okay, so the force equals the mass, which is 10, and the acceleration, which is 0.5. When we multiply those together, and we get 5, right? 5 newtons. So remember, to start the box, we need to fight friction and then accelerate. So to fight friction, we need this right here. We need to fight against that, which is right here. Okay, so 35 newtons south. To accelerate, we need 5 newtons. Wait a second. What direction are we going? Oh, plus we need to apply our 5 newtons south. Now we add those together, and we get 40 newtons south. Remember, the static friction opposes the start of the box. And then to keep it going, we're still going to have to fight that friction and accelerate it. It's going to take both. So to fight the friction now, we just need a little more than 25 newtons south. So to fight the friction will be 25 newtons south. And then to accelerate it is still going to take our 5 newtons from right here. 5 newtons south. So to keep it going is going to take 30 newtons south. Let's look at the next problem. A truck, which weighs 2,200 kilograms, has broken down and 3 men want to push it to the service station. How much force must be added to get the truck accelerating at 0.25 meters per second square west? The static friction in this case is 125 newtons, and the rolling friction is 50 newtons. Okay, remember, static opposes the start. So in order to get it started, you need a little more than 125 newtons. We want to go west, so we're going to have to push it west. This direction is wherever, whatever's it's opposing. Remember, he's a grumpy guy, that friction blob. He's really grumpy. Now to keep it rolling, remember, truck's on wheels, so rolling friction is what's going to be applying to those wheels as you're pushing them. You're going to need a little more than 50 newtons west. So I'm going to draw a picture. Okay, we're going to make a truck. Forgive my Dr. Seuss trucks. I guess you always have to forgive my drawing anyway. Shit, you. Okay, we're going to put a happy guy in the back. Here's a guy. Okay, so the force, what do we want to accelerate it? We want to accelerate it at, accelerate is 0.25 meters per second squared. Okay, our mass is 2,200 kilograms. And that's the only information it gives us. But we need to know what the force to accelerate is. So force is going to equal ma. That's our formula. So let's plug it in here. The mass is 2,200. The acceleration is 0.25. We multiply that out, and we get the force is 555 newtons west. Put west up here, west. Okay, remember, first thing you're going to do is start the car moving. You need to fight the friction. That's going to take some amount of force, and then you need to accelerate the car. So to fight the friction, to start, we're going to need a little more than 125 newtons. We're going to have that because we're going to add in this amount to accelerate it, plus 555 newtons west. So we're going to need, we add them together, we're going to need 680 newtons west in order to start the car rolling. And then to keep it rolling, remember, to keep it rolling, we're going to have to fight friction and accelerate it. So to fight friction while it's rolling, we'll need a little bit more than 50 newtons west. So we'll put 50 newtons west, and we're going to accelerate it, which again, this is what we need, plus 555 newtons west. So in this case, we are going to need 605 newtons west. Let me circle my answer here. Remember, you always need less force to fight friction once you're already moving. Now let's do a couple more of these problems. A 20-kilogram rock needs to be moved. Well, wait a second. Did we just do that one? Let me check up here. No, we did a truck. And we did 10-kilogram box. Okay, so we did not do that. Okay, so let's go back. A cart needs to be moved 100 meters east. It weighs 500 kilograms. How much force will be needed to move and accelerate it 1 meters per second squared? The static friction is 120 newtons. Remember that we're moving east, so this is going to have to be east. And this, remember, static friction is always against you moving. He's a nasty guy. Rolling friction will always be against motion. So in order to start it, remember, static friction opposes the start. You're going to need a little more than 120 newtons east, because that's the direction we want to move. To keep it rolling, you will need a little more than 15 newtons east. Okay, so let's draw a cart. I don't even know how to do this. A cart, and it's got a load in it, and it's got wheels. And we've got our Fricto blob down here. He's fighting that friction, and he's so nasty. He doesn't want to let it go. But then we've got our person right here pulling this cart along. So we need to know how much to keep it moving and how much to start it. And it has an acceleration. So first what we need to do is figure out how much acceleration, how much force do we need in order to accelerate it? Well, the formula for force is F equals ma. Okay, what is the mass of this thing? 500 kilograms. Oops. So, just a second, this is the mass. So the mass equals 500 kilograms, and the acceleration we want to get it to is 1 meter per second squared. Okay, so the force we're going to need to accelerate it is going to be our mass, 500, times the acceleration, which is 1, so it's going to be 500 newtons. And what direction did we need to go? East. So the force is going to need to be 500 newtons east. So to start this rolling and you're going to need to, let me fix that T. To start, you're going to fight friction, which is the static friction. So you're adding newtons in for that, and you're going to have to accelerate. So when you're fighting frictions to start, there's our friction to start. 120 newtons east. In order to accelerate, we need 500 newtons east, which is going to equal 620 newtons east. Okay, now to continue, to keep going, remember you need a little more than 50 newtons east. So you still need to fight friction and accelerate. So you need to still put in that amount of newtons to accelerate. So to fight friction, we need 15 newtons east. Plus, to accelerate, we still need 500 newtons east. You put them together and you get 515 newtons east. Okay, let's go down here and try this last problem. A 20-kilogram rock needs to be moved. If the static friction acting on it is 17 newtons east and the kinetic friction is 10 newtons east, how much force will be needed to move and accelerate the rock 3 meters per second squared? All right, so here's our rock. Whoops, maybe I shouldn't color it in. It would be more fun. But this way we can write in our 20 kilograms weight here. We've got our person who is pushing the block, and then we've got our fricto blob on the bottom. Our friction, which he's nasty. He doesn't want that thing to move. Okay, so what do we have? We need to start it going. So to start it, what are we going to need to put into it? Static is static. So the static friction acting on it is 17 newtons east. So to start it, we're going to need just a little bit more than 17 newtons west. Okay, then to keep it going, we need to fight that kinetic friction. And the kinetic friction is 10 newtons east. So we'll need just a little more than 10 newtons west. Remember, because we're accelerating, we want to move it west. So this is how many newtons it's going to take to fight friction. How many newtons will it take to accelerate it? So the force is going to equal the mass times the acceleration. What is the mass? 20 kilograms. Right here. What is the acceleration? 3 meters per second squared west. So let's plug this in. F equals our mass, which is 20, times our acceleration, which is 3. So the force is going to take is 60 newtons. So to start this rock moving, sliding along, we're going to have to fight friction and accelerate. Two different forces are going to need to be added. So to fight the friction, to start it, the static friction, we're going to need 17 newtons west. And then to accelerate it, we're going to need 60 newtons west. And this gives us just a little bit more. It gives us a little more than 17, so we don't need to worry about adding anything to the 17. So to get this started and get it accelerating, we're going to need 77 newtons west. Okay, so to keep it going, we're going to need to fight friction and accelerate it. So to fight friction, we're going to need 10 newtons west. And to accelerate it, we still need 60 newtons west. And we add those together and we get 70 newtons west. Okay, we'll circle those. Okay, thank you very much for watching. If you have any questions, please let me know. We'll see you next time.